straight to a NASA news conference where scientists are announcing a major science finding from their Mars exploration. Let's listen in.
From the Curiosity rover, we now know that Mars once was a planet very much like Earth, with warm, salty seas, with freshwater lakes, probably snow-capped peaks and clouds, and a water cycle, just like we're studying here on Earth with our Earth science satellites, the water cycle here on Earth. But something has happened to Mars. It lost its water. But we still have, in the atmosphere and on the surface, for the most part, but we still have this question of, did life arise on Mars once? And can we find out? And we have lots of intriguing clues about that story. Still, that begs the question about if life started on Mars some 3.5 billion years ago, did any survive? Is there any life on Mars today? And that's a fascinating question, one that's going to take some time to answer, but technologically, we can answer. And we can answer it by sending rovers, and we can answer it by sending people. And I look forward to that day on our journey to Mars. The discovery we're going to talk about today really is most exciting because it suggests that it would be possible for there to be life today on Mars. And with that, I'm going to turn it over to Jim Green to describe a little more detail and background.
Thank you very much, John. You know, we're making enormous progress with our current orbiters and rovers, as John mentioned. And this is really to look at Mars because it is the planet that's most like the Earth. It is, of course, as we've talked about, the destination for human exploration going beyond Earth. If we go back perhaps 3 billion years and take a look at Mars, Mars was a very different planet. It had an extensive atmosphere. And in fact, it had what we believe was a huge ocean, perhaps as large as 2/3 of the northern hemisphere. And that ocean may have been as much as a mile deep. So Mars indeed 3 billion years ago had extensive water resources. But something happened. Mars suffered a major climate change and lost its surface water. Today, we're revolutionizing our understanding of this planet. Our rovers are finding that there's a lot more humidity in the air than we ever imagined. As we ingest the soils, they're moist, they're hydrated, full of water. These discoveries are very important, but they were only part of the hydrological cycle on Mars that we're just now beginning to understand. What we're going to announce today is that Mars is not the dry, arid planet that we thought of in the past. Today we're going to announce that under certain circumstances, liquid water has been found on Mars. Now, to give more of a background on those results, let me turn it over to Mike Meyer. Michael?
Thank you, Jim. For the first time, we have orbital evidence of the agent that has enabled water to flow on the surface of today's Mars. For years, we've had orbital spacecraft imaging valleys, streaks, gullies. All of them looked like water was an agent. It had something to do with forming them, but we didn't have any proof. And it was not until about 4 years ago that we found the active process on Mars today that showed that water was a likely culprit. These are called recurring slope lineae, RSL, for the rest of the press conference to save everybody the trouble of saying recurring slope lineae. These are dark streaks that form in late spring, grow through the summer, and then disappear by fall. However, for 4 years, the scientific community has been unable to explain the waxing and waning of these dark streaks on the surface. During this time, additional observations have helped us determine that a broader distribution of RSL than we expected. We're also finding that they are in expanded latitudes. These observations have narrowed the constraints for how RSL might form, but there have been no evidence for water until now. It is through the multiple spacecraft and the multiple years of observations that we've been able to make this discovery of water on today's Mars. And for further details, I'll turn it over to Dwayne, who will pass it on to our scientist.
Yes, let's pass it on to our scientists in France and at Ames, and let's see what this excitement is all about. You're here first from Alfred McEwen from France, attending the European Planetary Science Conference, and then Luigi Oja. Alfred.
Greetings from Nantes. So I'm going to provide some background on the RSL, and I have to explain why we have such a horrible acronym to deal with here. For us scientists, it's better to have a purely descriptive name. That way we can argue about how these formed and still use the same name. We don't want a name that assumes we understand what these are. So we're stuck with RSL. And so I'm going to give a little background, and then I'll turn it over to Luigi to describe his new results. Could I have the first slide, please? So this first view is the title slide. It gives the title of the paper that's being released today in Nature Geoscience. And this is a perspective view as if we were on the ground. There's actually an orbital image, but we project it as if we're on the ground. And the black arrows there point to the tips of these RSL. They actually begin way up near the tops of this hill here. And they flow down over the bedrock, and when they flow out onto the fans at the bottom, that's where they stand out most distinctly. So these are the features we're talking about. And if I could go to the next view graph, this will show you a little animated GIF that shows you the time sequence of these features. So on the left is a black and white image. This is Pallikier crater, and it's all along the north-facing and west-facing rim of this crater. You can see the black arrows point to many of these on the left. On the right is this animated GIF, and it shows the sequence where these start to form in the early summer. They grow either gradually, very gradually, or incrementally. Then they stop growing and they fade. Then they disappear. They're gone entirely for most of the Mars year. The following Mars summer, new features appear and grow that are very similar. So that's the full sequence of events that we've been observing with HiRISE over the last 4 years or so. And these features are very sensitive to the temperature. They form at different times, at different latitudes on Mars, all related to the seasonal variations at those locations. So they're very temperature dependent. And the darkening and the temperature dependence can be explained if these are seeps of water that seep through the shallow surface layer and darken the very surface layer. But we had no direct detection of water. That was just our best guess as to what these were. If you go to the next slide, this is a global map of Mars, and it shows where we have what we call fully confirmed RSL. As of a couple of years ago, this needs to be updated, but it's the same general pattern. There's 3 regions. One is the southern mid-latitudes. Another is Valles Marineris in particular, and there are a few other equatorial spots. And then in the northern hemisphere, we've seen quite a few of these now in Acidalia planitia. Luigi was going to talk about his discoveries of hydrated salts in 3 locations that are marked on here. One is in Valles Marineris, in Coprades Chasm. Another is Pallikier crater, which I showed you the animated GIF for. And then we see them in the central peaks of Hale crater and Horowitz crater. And John mentioned the Viking results. Well, Norman Horowitz was the principal investigator on the pyrolytic release experiment on the Viking landers, which was one of 4 experiments searching for life on Mars. They had a negative result, although there may be reasons for that.
Well, there you have it. Big announcement from NASA that everyone was waiting for, definitive proof of water on Mars.
That's right, and it is liquid flowing water. This is a big deal because, of course, the question had been whether or not we knew there was frozen water, but the possibility of whether there was liquid water was something entirely yet unproven until this point. And what we heard the scientists say is that they've had multiple spacecraft, research that has been done now that leads them to this conclusion, and you hear them, they're speaking in very scientific terms of how it is they're able to determine that some of those dark patches that we saw in some of those images earlier are in fact water. They said that Mars is not the dry red planet that we once thought it was. We are going to have much more on this. In fact, our Bill Harwood, CBS News space consultant, is listening into this, and we are going to go ahead and talk to him in just a short time. But for now, we're going to take a quick break and have more news for you on the other side. You're watching CBSN.